One of the features that makes DevOps so really important is the ability to get new features out in your software really quickly. But to be able to do that, we have to have a great testing structure. And that's why in K14, we're looking at test-driven development and the test pyramid, so we can learn all about those important aspects. For a start, this knowledge area is actually 2 sentences. One is really short, test-driven development and the test pyramid. The next one is a little longer, how the practice is underpinned by unit testing, the importance of automation, appropriate use of test doubles and mocking strategies, reducing a reliance on end-to-end testing. The reality is, even with all of those words, it's probably not any clearer, which is why we're creating these little modules. Let's look a little bit deeper. So first off, let's make sure we understand what we mean by test-driven development, or what is commonly abbreviated to TDD. Very often in DevOps, people will talk about shift-left testing, where we're moving the tests to much earlier in our development cycle rather than leaving tests right to the end on the right at the end. In a traditional development environment, we would start off by writing our code. We would write our code, and once the code is written, we would probably go ahead and write a unit test for it, which is okay. Our software is still being tested, but it's not necessarily being created in the best way. If we consider our unit tests first, we really get into the nitty-gritty of the code and how it should be written. So then when we start writing our code with shift-left testing, we have already written our unit tests, so we know how to write great code from the start. So let's expand on the detail of a test-driven development cycle. First, we write our failing test for the new functionality. Then we can write the minimum amount of code to pass the test, before we can then look at refactoring the code to improve the structure and reduce duplication. And a glorious and big welcome through to my command line, where we can demonstrate the idea of developing your unit tests before we have created our code. It's really getting you to think about how to construct the code so it's going to be constructed in the best possible manner. So I'm working at my command line, and we will run through this in a live demonstration rather than just looking at code. In this way, you can really get an understanding of why we use unit tests. So I'm going to create myself a new directory. I'm just going to call it unit tests for no real reason, but it just becomes a convenient name to work with for the moment. So the name is fairly irrelevant. I'm going to use a command line editor, and I'm just going to create myself a very simple unit test file. So we're going to go in, and it needs to be called test_addition. It has to start test underscore, but we're calling it then test_addition.py, and we're going to import the unit test module as a standard module inside of Python, so we don't have to worry about installing the module. We're going to create ourselves a new class definition for the unit test, and we're going to call it test addition. Again, our classes must start tests for unit tests. And then we can instantiate it from the unit test and test case. So that's a template that we can bring in to make stuff available to us. In here, we can create ourselves a little test function. So def creates our function. And again, our function should begin with the word test and underscore. We can go through and say, look, we're just creating a simple test to add 2 numbers together. We'll have some form of calculator that we are creating. We can pass the object itself through to it. So that's the idea of self. And then we can go through and have our result is equal to our add function. Now, our add function we haven't created yet, but we're thinking about how we are going to create it. Well, we have to have a calculator that can add 2 numbers together. So I know this is very simple. However, we can look at how we create our tests first and making us think of then, well, what do I need to do in my real code? So we can then go through and run our test. So working on the object itself, running the method assert equal, which will come from the template test case, we're going to make sure the result is equal to 3 if we're adding 1 and 2 together. So that's our test. Now, of course, it's not going to run at the moment. There's a little bit more code we must put in, and we haven't actually created the code itself. So that's the next step that we need to look at. But we've gone through now, and it's going to be very easy to create our code because we know the name of the function and we know the parameters that we have to be passing through to the parameters. It has to be 2 numbers, 2 integers. So let's now jump back out of this file and open up our actual code that we need to write. So I'm just going to call this add.py. The add doesn't really matter, but remember we have to have a function called add. So that does matter. So we can define our function. From our test file, we know it has to be called add, and we know it must have 2 parameters. So I'm going to have A and B. Remembering here that we are passing parameters, not actual values, into the function. That's when we come to run the code. The function itself needs to return the result, which is going to be A plus B. Now, I know it's really simple, but that's all we really need in our production code. We know how to create the production code now because we've already named the function within our unit test file, and we know that it should be providing those 2 integers. If we go back now and take a look back in our test file, so our unit test file, so that the add function becomes available, we need to make sure that we import it. We've called it just add, so it's at the top level, so we can say from add, so from the add.py file, import the function called add. That's then going to relate to our result equals add 1 and 2. We can tidy this up a little bit by moving it down a couple of lines. And the final part to make sure that we actually do implement the test is to run a little conditional statement to make sure that we are actually running the unit test file rather than just importing it, to make sure then that the name of the running program is main. Obviously, they've got underscores in front and behind them. But we can then go through and run our unit test. So unit test dot main without any parameters being passed through to it. So this will mean then that we will run all of our defined tests. We just have one test. So let's go out and save this. And now we can go through and implement our test by running Python against our test_addition file. We've run one test, that test was okay, so we've passed the unit test. We developed the unit test first and then wrote our code so that it could pass the test. By implementing test-driven development, we have improved code quality. By writing tests first, developers are encouraged to think about the requirements and design before they actually get into coding. Reduced bugs. Writing tests help catch bugs early in the development process. Better design. TDD promotes simple and modular design as developers write only enough code to pass the tests. And documentation. Tests serve as documentation for the codebase, explaining how the code is supposed to work. Go on then, tell me about this test pyramid. Is that another one of those pyramids in Giza, Egypt? No. Not exactly. The test pyramid is a concept illustrating the different types of tests and their relative proportions in a robust testing strategy, emphasizing a larger number of lower-level fast-running tests and fewer higher-level, slower-running tests. Come on, let's take a look at this pyramid in a little bit more detail. When we expand on the detail of our test pyramid, at the base of the pyramid we have unit tests. These are the most numerous and form the foundation of our testing strategy. The idea of these is to test individual units or components in isolation. They're going to be fast and reliable and are usually relatively easy to write. Moving up, we have the middle layer for our integration tests. These are fewer in number compared to our unit tests, and their purpose is to test the interaction between integrated units or components within the application. They're going to be slower than unit tests, but are still relatively fast. Finally, at the top of the pyramid, we have end-to-end tests. These are the fewest in number, and their purpose is to test the entire application flow from the user interface all the way through to the back end. The characteristics of this is it's going to be relatively slow, complex and fragile, but of course absolutely necessary to ensure the quality of the entire application. Well, I still think it's where they found Tutankhamun, but never mind, let's move on. Let's take a look at testing doubles and mocking strategies. With testing doubles, these are a little bit like stunt doubles, but stunt doubles for our code. Perhaps when a module isn't written yet, but we need to create a test for it, we can use a mocking strategy to mock or act as a test double for our code. Let's look at what we mean by this. So here we are with a sample mock. When we look at this mock or our test double, we might use this when perhaps an external resource is going to be chargeable back to us. So it's going to cost us money running the tests. We might prefer to mock up the tests in our initial testing. So with this, instead of importing our original add module, we're importing unittest.mock, and from that patch instead of our add function. We go through our test in our normal way, but notice we're now using the decorator patch, saying that we are mimicking the add module and the add function. We can specify that we should return a value of 3, and our result should be then populated from running our mock add 1 and 2. So that should equal 3. We can test that it asserts to 3 when we run it once, adding 1 and 2 together. So in this way, especially if there is a unit cost against running our tests, we're not going to be financially in debt running our tests. We can run our tests as often as we want through the mock, and then perhaps finally running a few tests once we are happy that the mocks appear to be working. So let's jump out and actually check that our test double is doing really well. So we can run Python 3 and test add.py, and we can see then that this has succeeded. As I say, we might need to run a few more mocks, but if we're happy that the mocks are working, we can then perhaps implement the real add and make sure that we're getting the same results back. But this way, we can build a foundation for our testing to make sure before we have to actually then pay for the external resource that everything seems to be working. The more you can test with unit tests and integration testing, the less you have the reliance on end-to-end testing. But we've been taking a look at test-driven development, unit tests, integration tests, end-to-end tests, our test pyramid, and then looking at how we can use test doubles and mocking tests to reduce the end-to-end testing.
All that is left to say is thank you for watching. If you've enjoyed this, then you are probably sadder than I first thought. For more of this drivel, please subscribe, like and comment to @TheUrbanPenguin.